Welcome back, everybody. This video we're going to be talking about simplifying exponential expressions, but also applying them with some exponential growth and decay formulas. Let's look at this one first. Simplify x to the 15th over x to the 5th. And all of that is being raised to the 4th power. Well, like the order of operations, do what's on the inside first. When you have exponential terms and you're dividing, you actually subtract the exponents themselves. So x to the 15th over x to the 5th reduces to x to the 10th. And we got that 10 from simply taking 15 minus 5. Now we have a power of a power. And when you have a power of a power, you multiply the exponents. So our final answer here is x to the 40th. Let's look at another one here. Here we have power of a power with a coefficient. So this 4 is going to get multiplied to each of the exponents, and we're also going to raise 4 to the 4th here. 4 to the 4th, 4 times 4 times 4 times 4, we get 256. X to the 5th raised to the 4th is x to the 20th. Y to the 6th to the 4th is y to the 24th power. And that's our final simplified answer. Okay, now we're going to simplify radicals having an exponent. Now, you can look at this a couple ways. Square root of x to the 6th. If you take the square root of something, something times itself equals what's inside the radical. So we can rewrite this as x to the 3rd times itself. And then if I'm taking the square root of that, I'm just left with x to the 3rd. Another way to look at this is anytime you have a radical, you're really raising it to the 1/2 power. Square root means raised to the 1/2 power. And here we have power of a power. 6 times a half is x to the 3rd. That might be a little bit simpler to think about, but anytime you have a square root, think of it as raising something to the 1/2 power. Alright, now we're going to look at some exponential growth here, radioactive decay. So this is exponential decay. Radioactive chemical has an hourly decay rate of about 6%. How many grams of a 700 gram sample will remain after 80 hours? So here is just the formula for exponential decay if t is our variable. It's a times 1 minus the rate raised to the t power. A is the initial amount, r is the rate as a decimal, t is the time. So this problem, let's plug in what we know. The initial value is 700 grams. 1 minus the rate, 1 minus 0.06. Rate being raised to the 80th power. Alright, so it's just a matter of plugging that in the calculator. 1 minus 0.06, 0.94. So really it's 700 parentheses 0.94 raised to the 80th power. And rounding that to 2 decimal places, there will only be 4.96 grams remaining. Alright, let's look at another one. This time we have an exponential growth. Certificate of Deposit, or CD, earns 0.85% annual interest every 3 months. The interest is compounded. What is the value of a $42,000 investment after 5 years? So here's compounding interest. The amount you have is the principal that you invest. 1 plus the rate divided by the number of times it's compounded, raised to the power of the number of times it's compounded times the time in t. Alright, so let's plug in our values here. The principal amount, the original amount we invest, $42,000. 1 plus the rate, now 0.85% is really 0.0085. And then we're dividing that by 4, because I got the 4 because if I'm compounding it annually, but it compounds every 3 months, that happens 4 times. The number of times it's compounded a year is 4 times, because there's 4 sets of 3 months in a year. or raising it to the power of 4 times 5. Compounded 4 times a year times 5, that's 20. All right. Putting this in the calculator, we're going to get $43,821.50. And that is the compounding interest. All right, let's look at another one here. In the year 2005, a total of 850 fish were introduced into a man-made lake. The fish population was expected to grow at a rate of 8.3% a year. What will the fish population be in the year 2050? Round to the nearest whole number. All right, here's exponential growth again. Initial amount, 1 plus rate raised to the t power. All right, so initial amount was 850. 1 plus 0.083, that's 8.3% as a decimal, raised to the 45th power, because from 2005 to 2050, that's a span of 45 years. All right, plugging that in the calculator, rounding to the nearest whole number, 30,739 fish. So for 45 years, yep, that grows quite a lot. All right, next one, a little bit different, changing gears a little bit. Which equation can be used to find the solution? 1/3 e to the power of e minus 5 equals 81. Okay, well, a couple ways to do this. Get it rewritten here first, e minus 5. All right, so 1/3 to the power of e minus 5 equals 81. 81 can be written as 3 to the 4th. All right, so that what we want to do is get the bases to the same. Now 1/3. 1/3 can be rewritten as 3 to the negative 1. And then the power of a power I can rewrite like this, 3 to the power of negative e plus 5. And when your bases are the same, like they are here, you can just sort of ignore the bases, and then we have the equation negative e plus 5 equals 4, and that would match letter B here. All right, looking at another one that kind of has the same theme. All right, we're solving for y. 25y to the y minus 5th power equals 5 to the power of y plus 8. We need the 5 and the 25 to be the same base. 25 can be rewritten as 5 squared, and then we have the same basis. Power of a power, going to do 2 times y, 2y minus 10. Then we're down to, we can just ignore the bases and solve the equation. 2y minus 10 equals y plus 8. I can subtract y from both sides to give us y here. I can add 10 to both sides to give us 18. There we go. All right, next one. Let's look at another story problem here. The initial number of views for a blog was 20. The number of views growing exponentially at a rate of 20% a week. What's the number of views expected to be 4 weeks from now? Round to the nearest whole number. All right, once again, our exponential growth equation, f of t is equal to the initial amount, 1 plus the rate, raised to the power of t. Our initial amount was 20, but if I change 20% to a decimal, that's 0.2, raised to the power of 4. Round to the nearest whole number, the number of views should be 41 in 4 weeks. All right, thank you for watching. Hope this helped understanding of exponential growth, decay, and working with exponential equations.